All right, next question up. So first things first, read that question sentence. And what we're trying to find in this problem here is, what is the net elevation change from the starting point? So right over here, again, what is the net elevation change from the starting point? So to really wrap our heads around what that actually means, let me just show you a brief little example that really has nothing to do with this over here on the screen. Let me just show you. Everyone, quick question. If I started off at, let's go ahead and say 100 feet, and then I end up at 90 feet, what would you say my net elevation change is? What would you say it is? If I started at 100 feet and I ended at 90. Most people would say 10, but that's actually incorrect. When we're talking about net elevation change, the direction really matters. Everyone, yeah, the change is 10 feet, but is that going to be a positive 10 or a negative 10? And what to do here to get the right answer is base it off of the starting point. Everyone, if we start at 100, we're going down by 10 to get to 90. So that, quote, net elevation change in this case would be negative 10 feet. So, boom. That's what that means there, net elevation change. And once we have that in our heads, let's understand the rest of the problem. Here we go. Let me get this out of the way. And watch. A hiker starts at 5,400 feet, ascends at 600 feet per hour for 3 hours, and then descends at this rate for 2 hours. So here we go. I start off at 5,400. If I ascend at 600 feet per hour for 3 hours, that means I'm going up by 600 times 3, rate times time. And then if we descend right after that at 450 feet for 2 hours, well, guess what? That means subtract 450 times 2. So once we're there and once we read everything start to finish, let's understand where we end up at. Everyone, 600 multiplied by 3 gives us what? 600 multiplied by 3, that is a smooth 1,800. Absolutely. So I'll take that away, and I'll just say plus 1,800. 450 multiplied by 2, that'll give us 90. So I'll go ahead and replace that as well with minus 900. All right, sweet. Now let's see where we end up at here. So 5,400 plus 1,800 minus 900, that actually ends us up at 6,300. That is our final resting point there. So everyone, help me out. Here's our starting point. Here's our ending point. What's the difference? We can eyeball that and we can see that that's going to be 900. But is that going to be a positive 900 or a negative 900? Again, relative from where we start from 5,400, are we adding or taking away 900 to get to that final amount? Yeah, we're adding, absolutely. And so that's why the correct final answer is going to be D, 900. That's a positive because the net elevation change is a climb going from 5,400 up to 6,300. Again, that was a net elevation change of positive 900. All right, next question up. What we see here is, well, how much volume remains empty? So the full question sentence reads, after loading cargo that takes up this much space, how much volume remains empty? So one thing we need to understand is, to understand how much volume remains empty, after we loaded something, that's going to be subtraction. That's going to be subtraction. What we're trying to do here is, look, let me actually just read the entire story so you can, get the whole picture. We got a truck trailer that has these dimensions. It has a length, a width, and a height. So again, if we're taking a look at this truck trailer, we can go ahead and draw it like this if we'd like to. Something to this effect. So I can just draw out this little trailer, yada, yada, yada. And then from there, connect all the dots. Perfect. So we have this truck trailer. We can pretend that, the truck is actually over here. Here's the container. And we have these dimensions. We have a length, a width, and a height. And then we're saying, hey, look, after we're loading cargo that takes up, let's go ahead and say, this much space over here. Well, how much is left? And this is a subtraction problem all the way. If we fill in this part of the tank and we want to know how much is left, that is subtraction. We will subtract the volume of the trailer. We will subtract it by the volume of the load, of the cargo. So volume of the cargo. So once we find the individual volumes, we can subtract and we're done. That's it. Doesn't have to be any more complicated than that. So let's get to work. Let's move that out of the way, even though I missed the last little line there, no problem. Let's find these volumes. I already have the volume of my cargo right over here. So I'll just go ahead and put 960 cubic feet there. For the trailer, that's a rectangular prism. So that'll end up being length times width times height. My length is going to be 20 feet. My width is going to be 8 feet. And my height is 9 feet. So again, all listed in feet, so we're good. So we'll have 20 multiplied by 8 times 9. So 20 times 8 is 160. 160 times 9, let's see what that'll be. So that'll end up being 0. 6 times 9 gives us 54, carry the 5. And then 1 times 9 is 9. Carry the 5 is 14. All right, so we end up getting 1,440 cubic feet. So again, let's write that here, 1,440 cubic feet. So we're not done. That's not the correct answer because we have to subtract. That was the last thing we had to do. And so now we have 1,440 minus 960. That will give us the proper correct answer. And so let's just go ahead and write that down and do it over here. 1,440, 960, subtract. That's a 0. Then we'll borrow right there. 14 minus 6 gives us 8. Then 13 minus 9 gives us 4. And that is the difference in the volume, everybody. That is the answer, 480 cubic feet, which makes it answer choice C. And there we go, everybody. Again, this was a problem where, volume was involved, but it wasn't the only thing we had to do. We had to subtract, and that's how we got it. And let's go ahead and give this next one a shot. So at first, the first thing we always want to do here is read the question sentence first. So when we do that, we see that it says, what distance does it cover? So from right there, from the get-go, we know that we're looking for a distance. Now, we don't know that this is a distance, rate, time problem yet until we read the other two pieces. Yeah, we're looking for a distance, but until we're given rate and time, we don't really know that that's a distance, rate, time problem. Luckily, in that first sentence, it's given to us right away. A motorboat travels upstream against the current at 8 miles per hour for 4 hours. Okay, if this is all the information we're given, then we have our rate right there, 8 miles an hour, and then our time, 4 hours. So our formula that we're going to use, nice and easy, is distance equals rate times time, and we'll just throw everything in. 8 miles an hour is our rate, 4 hours is our time. Multiply those values together, 8 times 4 gives us 32, and there we go. That's going to be 32 miles, and the correct answer is going to be answer choice C. And there we are. There's a nice little warm-up for us, and I hope we're ready for another one coming right up.